Good afternoon, students. So today we are going to start with a new topic, that is haloalkanes and haloarenes. So what do you mean by haloalkanes? So haloalkanes are nothing but they are the alkyl halides. Okay. So here the halogen. So haloalkanes, they are the alkyl halides and they are the halogen derivatives of aliphatic hydrocarbons. Okay. So they are the halogen derivatives of aliphatic hydrocarbons in which one or more hydrogen atoms will be replaced by halogen atoms. So you know halogen atoms. So group 17 are called as the halogen atoms. Okay, so they have the general formula CnH2n plus 1x. Okay, so where X is the halogens that are fluorine, chlorine, bromine, iodine. Okay, haloarenes. Okay, so these are the haloalkanes. So haloalkanes are nothing but they are the alkyl halides and they are the halogen derivatives of alkanes with general formula CnH2n plus 1x. So in such compounds, the halogen atoms, okay, here they are attached to sp3 hybridized carbon atom. Now, what do you mean by sp3 hybridized carbon atom? Sp3 hybridized carbon atom means they are here the carbon atoms, they will have single bonds. Okay, so here the carbon atoms will be joined by single bonds. So I'll just show you. Okay. So suppose I'm writing, so this may be a alkyl halide. Okay, X. So X represents your any halogen group. Okay, so CH3. So CH3 you can see. So what is happening here now? If I take okay, so these are the halogen derivatives. So sp3 hybridized. So here the halogen atom. So this halogen atom is attached to sp3 hybridized carbon. What do you mean by sp3 hybridized carbon? That is carbon is attached to single bonds, right? Here, see, here it is. So here the halogen atom is attached to the carbon, which is a singly bond, right? So then it is called as sp3 hybridized carbon. Now the second term, what we are that is haloarenes. So what do you mean by haloarenes now? So haloarenes means they are aryl halides. Okay, so they are called as the aryl halides. So here the aryl halides, these are also the halogen derivatives of so these are also halogen derivatives of aromatic hydrocarbons. Okay, so these are also the halogen derivatives, but here they are the aromatic hydrocarbon. Aromatic hydrocarbons means what? They involve the benzene system. Okay, so in which one or more hydrogen atoms are replaced by halogen atoms. So here haloarenes, okay, haloarenes means what? Here they are attached to a aromatic ring. Okay, so they are attached to a aromatic ring and they are represented by this. How it is represented? This. Okay, so here it is represented. So this is a aryl group. Aryl group means aromatic group. Okay, aromatic ring, and there is a halogen. So that halogen is attached to a aromatic ring. Okay, now here what is happening? So here the halogen atom is attached to, in this compound, the halogen atom is attached to a sp2 hybridized carbon, right? So this is attached to what? It is attached to a sp2 hybridized carbon. It is attached to sp2 hybridized carbon. So this is a general introduction about haloalkanes and haloarenes. Understood? Okay. So next, we are going to see the nature of CX bond. Okay. What do you mean by nature? So this is a carbon bond, right? Carbon and halogen bond. So we are going to see the nature of the CX bond. So you know halogen. So they are the group 17 elements. So this halogen atoms, they are what? They are highly electronegative atom, right? So they are highly electronegative. So what they will do, they will tend to pull the electron towards itself. So when the halogen atom is attached to a carbon. Okay, so here what it will tend to do, it will tend to pull the electron towards itself. So as a result, what will happen? The electrons are completely the halogen, it will tend to pull the electron towards itself, and when it is leaving, the halogen will take along with it the electrons, and the carbon will be left with a positive charge. Okay, so what it will do, so when the it will tend to pull the electron toward itself, so there will be development of charges. So that is, halogen will be partially negative, and carbon, it will have a partial positive charge. Okay, so CX bond. So since the halogen atom is more electronegative than carbon atom, what it will do, it will tend to pull the electrons towards itself. Okay, so as a result, there will be development of partial positive and partial negative charge. Okay, so hence CX bond is called to be a polar bond. So why it is? It is due to minus I effect, inductive effect. Okay, why? Because halogens are highly electronegative. So as a tendency, it will tend to pull electron towards itself, and there will be development of charges. Okay, so we'll go for the next one. I hope this is clear. Okay, so next we'll start with the classification. Now, what do you mean by classification? We are going to classify. Okay, so based upon the first classification is based on the number of halogen atom. On the basis of number of halogen atoms. So it may be classified as mono, di, or poly. That is tri, tetra, etc. Depending upon whether they contain one, two, or more halogen atoms in their structures. Okay. Now, first we'll see about haloalkanes. So here you can see there is one halogen atom. Here in the second example, two halogen atoms are linked. Here there are three halogen atoms linked, right? So when one halogen atom is linked, then it is called as monohaloalkane. Okay, when there are two halogen atoms linked, then they are called as dihaloalkanes. When there are three halogen atoms linked, they are called as trihaloalkanes. Four, tetra. Okay, so more than two, okay, or more than three are called as polyhalogen compounds. So mono means one, di means, so based on the number of halogen atoms, how many hydrogen atoms are replaced by halogen atoms? Okay, so based on the number of halogen atoms, they are classified as mono, di, and polyhalogen compounds. Okay, so this is about haloalkanes. Haloalkanes means what? They are aliphatic. Aliphatic means what? Straight chain compounds. Okay. Then second example is what? Based on the haloarene. Okay, haloarenes. So in haloarenes also, if there are only one halogen atom, then it is called as monohaloarene. Okay, if there is one halogen atom, then it is called as monohaloarene. If there are two halogen atoms, then it is called as what? Dihaloarene. Okay, then here you can see there are three halogen atoms, and it's called as what? Trihaloarene. Okay, so here also same, based on the number of halogen atoms, how much they have attached to a aromatic ring, right? Here only the change difference is what? Here it will be a straight chain compound, and here it will be a ring compound. Okay, it will be a ring compound. So based on the basis of number of halogen atoms, it is classified like this. So next classification we'll see. So based on the hybridization. Okay, next is based on the hybridization of carbon atom. So first is compound containing sp3-CX bond. Now you know what is hybridization. Okay, so it is mixing of orbitals, right? Now hybridization, when we are talking about sp3, I'll give you a brief idea. Okay, just what is sp3, sp2, and sp. sp3 means what? Now, so I'll just give you first examples. Okay. Now, if I ask you what is the hybridization of this carbon, if I ask you what is the hybridization of this carbon, if I ask you what is the hybridization of this carbon and this carbon. Okay. Now here, when the carbon is linked singly, okay, if it is linked singly to the hydrogen atoms, then it is said as sp3 hybridized carbon. Okay, so this is sp3 hybridized carbon. Here also, the carbon is linked singly to two other hydrogen atoms, right? It is attached singly to the hydrogen atoms. So this is also sp3 hybridized. Okay, easy way to remember. Now here it is linked to the other carbon with double bond. So it is sp2. Okay, and here it is linked to what? It is linked, this carbon is linked to 3 bonds. So it will be sp. Okay, remember like this. When it is singly bond, it is sp3 hybridization. When it is doubly bond, it is called as sp2 hybridization. If it is triply bond, then it is called as sp hybridization. Okay, now we'll see, based upon the hybridization of carbon atoms, if the compounds are containing sp3 cx bond. Okay, if the compounds are is containing sp3 cx bond, a alkyl halides, that is rx bond. Okay, first is that is alkyl halides, that is rx bond, if it is containing the alkyl halides. So in such compounds, if the halogen atom is bonded to a aryl group, okay, alkyl group, then we have seen the general formula, that is CnH2n plus 1. Okay, so X. So this is the general formula which you need to remember. For CET, they may ask you what is the general formula of aryl halides. Okay, alkyl halides. Then you have to write it as CnH2n plus 1 X. Okay, so this can be a question. Then so based upon the hybridization, so they are classified as 3, that is primary, secondary, and tertiary alkyl halides. So if carbon is attached to only one alkyl, okay, if carbon is attached to only one alkyl group, then it is called as what? Primary. You can see there is attached only one alkyl group attack. Now here, if you okay, so now here, if the what you can say, if compounds are containing here the carbon is containing 2 alkyl groups, right? Carbon is containing how many alkyl groups? 2 alkyl groups. Then what it is said to be? Then it is said to be secondary alkyl group. Okay, it is called as secondary alkyl halide. Okay, so this is primary alkyl halide. Halogen atom is attached to the carbon which is having 2 alkyl groups. Okay, so it is secondary. Here halogen atom is attached to a carbon which is having only one alkyl group. Okay, then it is called as primary alkyl halide. Now the third one, here the halogen atom is attached to the carbon which is having 3 alkyl groups. Then it is called as what? Then it is called as tertiary alkyl halide. Okay, then it is called as what? Tertiary alkyl halide. So this is the first classification, that is based on the alkyl halides. Then second is allylic halides. So next we'll go for allylic halides. So what do you mean by allylic halides? So allylic halides, in this the halogen atom is bonded to sp3 hybridized carbon which is next to a carbon-carbon double bond. Okay, so here what is happening? Here the compounds, okay, in this the compounds, the halogen atom is bonded to what? It is bonded to sp3 hybridized carbon which is next to a carbon-carbon double bond. So I'll give you example. Okay, so this is an example. So what is happening here? The halogen atom is attached to a carbon which is sp3 hybridized, right? So this is sp3 hybridized because it is linked by single bonds. So the halogen atom is attached to a carbon which is singly bond. Okay, it is sp3 hybridized which is next to a carbon-carbon double bond. So this is a carbon-carbon double bond, right? So this is a allylic halide. So this is the first example. If I write it CH double bond CH, CH2X. Okay, so CH2 double bond. So this is what? The halogen atom is attached to a sp3 hybridized carbon which is next to a carbon-carbon double bond. So this is an example of allylic halides. Okay, so same with respect to aryl halides also I can give. So if this is a halogen atom, so halogen atom is attached to a carbon. Okay, so which is next to a carbon-carbon double bond, right? So halogen atom is attached to a carbon which is sp3 hybridized, which is next to a carbon-carbon double bond. So this is the allylic halides. So next is benzylic halides. So what do you mean by benzylic halides now? So in this compounds, the halogen atoms is attached to a sp3 hybridized carbon which is next to a aromatic ring. So what is benzylic halides? The halogen atom is attached, it is bonded to sp3 hybridized carbon atom which is next to a aromatic ring. So I can give you example like this. So this is aromatic ring and the halogen atom is attached to a this, right? So halogen atom is attached to a carbon which is sp3 hybridized which is a link to a aromatic ring. So this is called as what? This is called as benzylic halides. Understood? Okay, so these are the second classification based on the hybridization of sp3-CX bond. So when you have a sp3-CX bond, so these are the further classification. So next we'll see the compounds which are containing sp2-CX bond. Okay, first is vinylic halide. So what is vinylic halides now? So vinylic halides, the compounds in which the halogen atom is bonded to sp2 hybridized carbon atom of a CC double bond. Okay, so these are the compounds in which the halogen atom is bonded to sp2 hybridized carbon atom of a CC double bond. So I can give you examples. So see, this is CH2, CH and X. So this is an example of vinylic halide. So here in the allylic halide, what was there? The halogen atom is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. Okay, in vinylic halide, what is the okay, difference in vinylic halide, the halogen atom is attached directly to the carbon which is linked to a double bond. Okay, or it is having a double bond. So this is an example. So vinylic halide. So this is an example for vinylic halide. One more example for okay. So this is the aryl halide, right? So this is also a vinylic halide. So you can see when you have a ring system. Okay, so the halogen atom is attached to a sp2. So this is also sp2 hybridized carbon of a double double bond, CC double bond. Okay. Next is aryl halides. So in this compound, the halogen atom is bonded to sp2 hybridized carbon atom of an aromatic ring. Okay, so directly the halogen atom is attached to sp2 hybridized carbon of a aromatic ring, right? So this ring, this carbon is present for the aromatic ring. Okay, so compounds which are containing sp2-CX bond. So that is vinylic halides and aryl halides. So we have seen this. Vinylic halide is what? A halogen atom is attached to a carbon which is sp2 hybridized of a CC double bond. What do you mean by aryl halides? So aryl halides, the halogen atom is attached to sp2 hybridized carbon of an aromatic ring. Okay, so these are the based on the hybridization. Okay, so this is the classification. So from alcohols, no. So first, what we'll do based on this introduction. Okay, based on the introduction and classification, we'll solve some MCQs and then we will go for methods of preparation. Okay. So okay, so the first question is monohalo, dihalo, trihalo, and tetrahalo are types of haloalkanes and haloarenes based on the okay A type of halogen atom, B number of halogen atom, C nature of a carbon atom, D hybridization of carbon atom to which the halogen is bonded. So we have seen this, right? So classification when you have based on the number of this what when you have monohalo, dihalo, trihalo means what? Mono means one, di means two, tri means three, tetra means four. Halo means what? Halogen compound. So when you have one, two, three halogen compounds, so it is what? So this is classification based on the number of halogen atoms. So option B is the answer, right? So when you have, so it is based on what? It is based on number of halogen atoms. So based on the number of halogen atom, it is classified. The haloalkanes and haloarenes are classified. I hope this is clear. So we'll go for the next question. So next question, a monohaloarene. Okay, a monohaloarene is an example of, what do you mean by mono now? So I'll read out the options first. A, aliphatic halogen compounds. B, so first is aliphatic halogen compound, B is aromatic halogen compound, and C is alkyl halide, and D is side chain substituted aryl halide. Okay. Uh, so a monohaloarene is what? So monohaloarene means what? What do you mean by mono? Mono means one, right? Um, So mono means one, halo is halogen compound, arene is what? Arene is a aromatic ring. So it is example for what? It is example of aromatic halogen compound. So again, B is the correct answer. I hope you have understood. So mono is what? One. Okay. Mono is one, aromatic is, sorry, mono is one, halogen, halo is halogen compound. Then what? Arene is a arene is a aromatic ring. Okay, I hope this is clear. Yes. So this is the correct answer. So aromatic halogen compounds are nothing but haloarene compounds. Okay. So we'll go for the next question. What is the general formula for haloalkanes? Right. General formula for haloalkanes. Alkane means what? Again, the straight chain compounds. Okay. So when you have straight chain compound, then they are called as what? Alkanes. Okay. Aliphatic alkanes. Then so that is when you have halogen, X is what? Halogen atom and N is a 1, 2, 3, 4. So what is the formula? CnH2nX, CnH2n plus 1x, CnH2n minus 1x, CnH2n 2n minus 3x. So the answer is what? The answer is B, right? We have seen this. This given. What is the general formula of haloalkanes? When you have alkanes, it will be CnH2n plus 1. Okay. What is there here now? Haloalkanes is there. So it is CnH2n plus 1x. Okay. So option B is the right answer. I hope you have understood. So we'll go for the next question. So which of the following compounds contains an allylic carbon? Okay. Now we have seen what is allylic carbon. What do you mean by allylic carbon? Yes. What do you mean by allylic carbon? So allylic carbons, the halogen atom is bonded to sp3 hybridized carbon, which is next to a carbon-carbon double bond, right? So which is the example which we have seen? Yes, halogen compound, right? So it is a allylic carbon in case of aryl groups, right? It is a ring structure. So it is a A. Okay, A is the correct answer. Oh, right. So which of the following compounds it contains allylic carbon? So we have discussed what is allylic carbon. So allylic carbon means what? Allylic carbon means the halogen atom is bonded to sp3 hybridized carbon, which is next to a carbon-carbon double bond, right? So when you have a halogen atom which is linked, so this is a halogen atom, right? Halogen atom is linked to a what? So this is a carbon which is sp3 hybridized and which is next to a carbon-carbon double bond, right? So this is the example for a allylic carbon, right? So answer A will be the right answer. So we have discussed this. So we'll go for the next one. So which of the following categories does the compound shown belong to? Okay. So this is a compound which is given. So it is like this. Okay, a ring, not an aromatic ring. Okay. So cyclo ring you can say, cyclobenzene. Okay, not benzene also, right? So cyclo ring it is. Uh, So what is the example? So which of the following categories does the compound belong to? A, primary haloalkane, B, secondary haloalkane, C, tertiary haloalkane, and D, haloarene. So this is what? So this is a this is what? So this is a halogen group, right? Halogen atom. So halogen atom is linked to a carbon. Okay, halogen atom is linked to a carbon which is linked to further two carbon, right? Right. So halogen atom is linked or halogen atom is directly linked to a one R group. Don't go for so much detail. So halogen atom is linked to one R group. R group is what? One alkyl group. So what it is? It is a primary haloalkane. Okay. It is a primary haloalkane. So option A is the right one. So halogen atom is linked to R group. So R here is what? It is a aryl group or it is a Okay, so this is the answer. So A is the answer. So primary haloalkane. Okay, primary haloalkane. So we'll go for the next one. So what is the nature of the circled carbon atom in the following compound? So when you have a compound, so this is a compound which is given. So here you can see this is a carbon which is marked. So you have to tell what is the hybridization or what is the nature of this compound. Okay. So this is a halogen group, right? So this is a halogen group. This is a aromatic ring. Now what is the nature of the circled carbon atom? Yes, is it sp2 hybridized? Is it allylic? Is it benzylic? Or it is a vinylic? Right. We have seen what is sp2 hybridized. Sp2 hybridized means what? It should have a double bond. Okay, so it should be linked to a double bond. But no, this is linked to what? This is linked to two. Right. What do you mean by sp2 hybridized? Yes, sp2 means what? That carbon should be linked to a double bond. So this hybridization will be then sp2. But here this carbon is linked to next carbon. Okay. Uh, which is double bond. But here there is no double bond. So this is not sp2, but this is sp3 hybridized. So first option is wrong. Second is allylic. What did I say? What is allylic halide? So here the halogen atom is linked to a carbon, which is okay. A halogen atom is linked to a carbon, which is sp3 hybridized, which is next to a carbon-carbon double bond. So halogen atom is there. There is a sp3 hybridized carbon, but this which is next to a carbon-carbon double bond. So allylic halide. Okay, but this is not an example for allylic halide. Okay. Then next is what? Benzylic. What do you mean by benzylic halide? Yes, what do you mean by benzylic halide? So benzylic halide means what? Here the halogen atom is directly attached to a carbon, okay, which is sp3 hybridized, which is next to a aromatic ring, right? This is uh, this is linked to what? This is linked to a aromatic ring. So benzylic. So option C is the correct answer. So here what you can see is halogen atom is directly it is attached to a carbon atom which is sp3 hybridized, which is linked to a aromatic ring. So option C is the right answer. And we have seen what is vinylic halides. So what do you mean by vinylic halides? So vinylic halides, here the halogen atom is bonded to sp2 hybridized carbon atom of a cc double bond. Again, I'll give you example so you can just understand. So if I give in ring structure, so it will be like this. So halogen atom is attached to a carbon which is sp2 hybridized of a carbon-carbon double bond. Okay. So this is the nature of the carbon atom. Understood? So it is benzylic. Right? It is a benzylic carbon. It is called as benzylic. So C is the correct answer. Next question. In which of the following cases will be the compound tertiary halogen compound if X is equals to halogen atom? So when, in which case the compound, the following compound will be tertiary in nature? Yes, we have discussed this in alkyl halide, classification in alkyl halide. So based upon the hybridization, okay, if the carbon is attached to only one alkyl group, then it is primary. The next will be this will be primary alkyl halide. Okay. Then if the carbon, if the halogen atom is attached to a carbon which is next to a two alkyl groups, then it is what? Then it is a secondary. Then if the halogen atom is attached to a carbon with the three alkyl groups, okay, then it will be tertiary. Okay, it will be tertiary. So here, in which case it will be tertiary? When this both okay, this is one R. Okay, this is one R, that is a aryl group. Okay, now there are two R groups. So these are this should also be alkyl group. Now this, see here, this will be the case. Now this, suppose this is a aryl group. Now what these two also will be, this should also be alkyl groups. So what will be the answer? D. Okay, R dash and R double dash should be CH3. Okay, so option D will be the answer. So if H is there, H won't be, if you take one H and one R, that is sorry, one CH3, then it will be what? It will be secondary. Okay, if you take both R dash and R double dash as hydrogens, then it will be primary alkyl halide. Right, so the number of the alkyl groups if there are more. Okay, if it is one, then it will be primary. If there are two alkyl groups, secondary. If there are three alkyl groups, then it will be alkyl or aryl group. Okay, then it will be tertiary in nature. So option D. So here there are only two options, either hydrogens or CH3. So if R dash and R double dash is CH3, then it will be tertiary in nature. So option D will be the right answer. So we'll go for the next one. Which of the following is a vinylic halide? So now you have to tell which among the following is vinylic halide. You know what is vinylic halide? So vinylic halides are compound in which the halogen atom is attached to a carbon, okay, which is sp2 hybridized of a CC double bond. So this will be the option. Now seeing this, you have to answer which of the following will be example for a vinylic halide. Yes, so which of the following is a vinylic halide? Yes, seeing this example. So CH2, if I write CH2 double bond CH, okay, then this is Cl, this is Cl, okay, and this will be CH. So is it the halogen atom is linked to a carbon which is next to a double bond? No, this is wrong. Okay, it is not like this. So this carbon should be directly to a double bond. Wrong. Then second one, CH3, CH, Cl, then CH3. No, this is also wrong. There is no double bond only. Then next option, CH3, C, CH3, then double bond CH, then CH, okay, and Cl. So halogen atom is attached to a carbon which is a double bond. No, this is also wrong. Then last one we'll see. So not C option also. Okay, there is no. Then we'll go for the last one. CH3, CH, then CH, then it will be double bond C, Cl, CH, H, and CH3. So halogen atom is attached to a carbon which is having a double bond. Okay, which is sp2 hybridized of a double bond. Right? Is it similar? Right. So this is also similar. Right. Halogen atom is attached to a it is bonded to sp2 hybridized carbon atom of a CC double bond. Okay, so this is the answer. So option D is the right answer. I hope it is clear. Okay, so we'll go for the next question. So the compound C6H5F is an example of which halide? So I'll illustrate. So C6H5F. C6H5F. So what is the example for? Is it a allylic halide, benzylic halide, vinylic halide, or aryl halide? Okay, what do you mean by aryl halide? So the halogen atom is directly linked to a aromatic ring. Okay, so you can see that the halogen atom is directly linked to a aromatic ring. So yes, good. So it will be option D. It will be option D, that is aryl halide. Right. So the compound, when you have, we have seen now uh what is allylic halide, okay, what is benzylic halide, what is vinylic halide. So aryl halide means what? The halogen atom is directly linked to a aromatic ring. Next question. The compound in which a CH2Br group is attached to a benzene ring is an aryl halide. Is it true or false? So if you have a compound, okay, suppose I'll write the structure. You have a compound. Okay, now this is a compound. To this CH2Br is there. Okay, so this is it a aryl halide? Is it an example for aryl halide? True or false? Yes. Is it an example for aryl halide when you have CH2Br group and it is linked to a aryl halide, to a aromatic ring? Is it an example for aryl halide? Is it true or false? We have seen just now previous example. Okay. So this was the halogen atom. When it is linked to a aromatic ring, then it is called as aryl halide. So this is what? This is a benzyl halide. This is a benzylic halide. Okay, so this is example for benzylic halide. So it is false. Okay, the compound to which CH2 group is attached to a benzene ring is a not aryl halide, but it is a benzylic halide. So it is false. I hope it is clear. So we have completed the introduction and classification. Okay, so we have to start with the methods of preparation. Okay, so we have very less time, so this will take more time. So methods of preparations, that is from alcohols. Then we are going to see methods of preparation of haloalkanes from alkenes. Then we are going to see halide exchange methods. Okay, so we are going to see some of the important name reaction. So based on this, then further we are going to solve MCQs. So this we'll see in the next class. Okay. So today's session, I'll end it here. So we can will meet on the uh, in the next week. Okay. So I hope it is clear. So I'll end the session here. Thank you. We'll meet again.